All right, it says for each set, identify the strongest acid. This is really important. It comes up a lot in other chemistry courses, including organic chemistry, so I want to spend a minute on it. So if we have a weak acid, HA, aqueous, and we react said weak acid with water, it will be in equilibrium with H3O plus aqueous plus A minus aqueous. So the higher the concentration of H3O plus, the lower the pH and the stronger the acid. So Ka here is products over reactants. Ka is just like Kc, except it's for acids. All right, it's concentration of H3O plus over times concentration of A minus, the products, over the reactants. Note that H2O doesn't count because it's a liquid, over the concentration of HA, like so. So when the H3O plus concentration is high, so if we have a high concentration of H3O plus, meaning we have a relatively strong acid, the Ka will be relatively high. Okay, so when this is high, this is relatively high, just because of the math, right? If this is a bigger number, this is going to be a bigger number. Note that a bigger number is close to 1, so 1 times 10 to the minus 3 is a bigger number than 1 times 10 to the minus 6. All right, so this is going to be a relatively big number. Let's look at the pKa. The pKa is equal to the negative log of the Ka. All right, when you take the negative log of a large number, you're only looking at the exponent. So if you have the Ka equals 1 times 10 to the minus 3, or a Ka equals 1 times 10 to the minus 6, all right, as two Kas, if you take the negative log of this, this is 3. If you take the negative log of this, this is 6. So when the Ka is high, or it's a strong acid, the pKa, is relatively low. All right, the pKa is relatively low. This is much larger than this, right? It's 1,000 times bigger. So this is 1,000 times stronger acid than this. Its pKa is lower. So strong acid, high H3O plus, means large Ka and small pKa. That's the take-home message of this. So let's identify the strongest acid in each set. We're looking for the largest number. Now, if the exponents are the same, then you actually look at the coefficient to see which one is the largest. But in this case, the exponents are not all the same. So the exponents here are all different. So the largest number is the smallest exponent because it's a negative exponent. So this is going to be your largest number and therefore your strongest acid. Remember, the pKa's are the opposite. The smaller the pKa, the stronger the acid. All right, chemists will tend to like to use pKa's like they like to use pH's instead of concentration of H3O pluses. So it's important to remember that the pKa is smaller, the acid is going to be stronger. If the Ka is larger, the acid is going to be stronger.